Hello everyone, I'm Dr. Anil Shirahatti, a professor and consultant. So in today's session, that is session 9 on module 3, we will be working on problems on compound interest and we will be using compound interest factors tables. Okay, so let's start with the first problem. So what the problem statement says, a man is planning to build his own house. Okay, so a man is planning to build his own house. He plans to divert his bonus of rupees 40,000 as an investment every year for next 10 years. The bank gives 12% interest rate compounded annually. Find the maturity value of his account after 10 years. So what is happening in this case? A person is planning to build his own house and he wants to divert some amount as from his salary as an investment. So whatever the bonus he is getting, he is investing from his side. So every year he is investing rupees 40,000. Okay, at the end of every year he will invest for next 10 years. Okay, in a bank, and the rate of interest what he is getting is 12%. Okay, and you have to find what is the maturity amount value at the end of the 10 years. So if you see, if I calculate the given values in terms of symbols, all of you have to remember is F is for future amount. Okay, P is for present, any annual payment receipt uh, or expenditure is denoted by A. Okay, now the period, either you can use small n or capital N. Okay, and rate of interest is denoted by I. So in this case, that's the amount is annual payment. I have used A, that is 40,000, number of years 10 years, rate of interest 12%, maturity amount or the future amount which I have to find. So let's first thing, in every problem you have to draw the cash flow diagram. Once you draw the cash flow diagram correctly, it is very easy to solve the problems. Okay, so read the problem statements 2 to 3 times to understand where the cash is coming in and where is the cash is going out, and at what time, what are the periods in the first year is happening, 0th year, that everything you have to understand very clearly. And for this reason you have to read the problems 2 to 3 times and draw cash flow diagram correctly. So you should, main concentration should be cash flow diagram. So what happens the cash flow diagram? So as we say, first we try to draw the time frame. So here 0 to 10 years, so the time frame is done. You represent 0 to 1. So every year he is depositing 40,000. So what is happening, amount is going out of his pocket and going to the bank. So every year, at the end of first year 40,000, at the end of second year 40,000, at the end of third year 40,000. So like this he go on paying till 10th year, and the bank will give him an interest of 12%. And at the end of 10th year he wants to find what is the future amount he may give, because now he is standing here. Okay, so this is happening in future, that's why that is unknown. Now if we see our last session, this can be calculated using the formula. So what was the formula? F is equal to A multiplied by 1 plus I raised to n minus 1 divided by I, where A is nothing but the amount, that is 40,000 constant. What is I? That is 12%. What is the number of years or period? It is 10 years. So if I substitute this one, I got a value of around 7,01,949. So very easy. But if you think, instead of this one, in some years if he deposits more amount or some again he is to withdraw some amount, this equation will become more and more complicated, because here some plus may come, some minus may come. So that's why, that is the reason we are moving, instead of using this equation we will move towards the compound interest table. So how this is the simple representation of compound interest table. So I'll show you the table also. So if you see this one, this is the 12%. Okay, so that is the interest rate table for 12%. Here N is the period. So this you may consider as a year, you may month, it is left to you. Okay, so this is a just the value for N. Now we have shown there are factors, that is for single payment, that is the relationship between F and P. These are the constant. Okay, the present worth P by F relation, these are the constant with respect to N. Okay, for sinking fund this is A by P, F by A, P by A by G, P by G, N. So you can see for each interest of say X, so it may be 1%, 2%, 10%, you can get like this table. So I will show you this table in a big this one. So you can see this is the interest table. Okay, so you can see here this is for 0.25%, 1 by 4%. So like this you can get for half percent. It's a big, so you can see this is 1.25%, 3%, so you can see here 8%. Okay, so 9%. So you can see number of years, okay, or periods against the constant values. Okay, so this is what we are interested, because this constant values are nothing but whatever the value you are getting here. So you don't have to use this, you can directly get from the tables. So let's do for the first one here. What is F by A? I comma N. So what is the value for I? I is 12% and N is 10 years. So if I see this table, and we are interested in F by A table, constant values. Okay, so first you go to the uh, table of 12%. So in this case I'm showing you this is the 12%. Okay, and we are interested in F by A value. So we have to go against that column. So we are interested in F by A, and so in this case I is done, that is 12%, F is done, that is F by A. So if I write this equation for you, so the equation is I'm interested in F by A and I is 12%, okay, and N is 10. Okay, so if I write this equation, interest rate 12, it is done. What F by A? I'm interested in this column, and what is N? N is 10. So I have to go here. Where is N is 10? N is 10 here, and I have to go against this values. Okay, so here N by 10. So what the constant value is? 17.549. So there are different tables. Some tables will give till 3 decimal places, some table may give till 4 decimal paper tables, and it is left to you. There will not be much difference in the final answer. So in this one I have used other tables where I got 17.54874. So it is almost same. So if I multiply this one, you got an answer as 7,01,949. So approximately same answer you will get when you are using these tables or you are using the equations. Okay. Now let's go to the second problem. What is the second problem says? A certain piece of equipment in a computer CPU saves rupees 8,000 per year in material for 6 years. If the sales organization has to earn 18% rate of return, how it could justify now for the purchase of this piece of equipment? Okay. So what is happening? A certain piece of equipment in a computer is used and it saves rupees 8,000 per year for next 6 years. Now they have to justify the purchase if the rate of return, okay, or is 18%. Okay, so in this equation we know if I draw the cash flow diagram, it is from 0 to 6 years. Okay, and every year there is a saving, so the money is saved. That means there is money coming in. So that's why A is constant 8,000 and the rate of interest is 18%, and we want to find what is the present worth of that method. Okay, so in this case we have to justify, we have to find a value of B such that the rate of interest is coming, rate of interest or rate of return is coming 18%. So this is the relationship between P and A. Okay, now using your simple equations, if I am doing it, you can see the present worth is equal to A into whatever this equation. So as you go more and more, this equation is becoming more and more complicated. So A is 18% and N is 6 years. If you solve this one, you got a value of 27,980. But instead of this one, I can still use the table also. So what I have to do, if I am using the table, P is equal to A. Okay, then numerator by denominator. Numerator is the unknown, that is P, divided by the known A. Okay, so this is nothing but, even P is known to A is known to you, this is unknown. Okay, comma I is 18%. Okay, and what is the period? N, that is 6 years. So if I find this constant value from the table, multiply with this A value 8,000, I will get approximately same answer. Now this is what I am interested to do. But let's say in this example the rate of interest for 18% is not given. Okay, just to show how you can do interpolation. So rate of interest available with you is, okay, that is this constant value, whatever it is available for 15% only, that is 3.78448, and for 18% it is 3.32. There is no direct table available for 18%. Then how I should calculate? So one can do this one using interpolation method. So how to do interpolation? So if I have to find for 18%, I have to take the constant value for 15%. Then what is the difference between 18 and 15? That is a 3. And then I have to do this multiplication. That is constant of 20, that is constant of 15, then 20 by 15. So this is the unit change in the number when it is moving from 15 to 20%. Okay, so every change, so 15, let's say you are having 5 and this is having, let's say, value of 10. So what about 16? It will be another one, that is 6. Like this I can calculate. So this is what that multiplication factor for each change. Okay, and here as it is 18, I'm having a difference of 3. Okay, so 18 minus 15 plus 3, and if I do this one, the constant value comes as 3.509098. So this is a simple interpolation method. Even I can do the reverse. I can take the constant value for 20% and do this one. In that case, instead of plus, I have to use minus sign. Okay, because I am moving back. So if I substitute that one, again I am getting as approximately same value, that is 28,072. Now let's go to the third problem. In this third problem, a person, if a rupees 50,000 is deposited into a saving account that earns 13% per year, what uniform annual amount should be withdrawn at the end of each year for 15 years so that nothing would be left into the account after 15th year draw? So what is saying, if a person wish to deposit rupees 50,000 now, okay, you can see he's depositing, so P is 50,000, so he's depositing 50,000 now at the 0th year, and every year he wants to remove amount in the equal installment of 15 years, that is till 15th year, and the amount should be constant. and the bank is giving a rate of interest rate of 13%, and we want to find what should be that value of A. So this is the relationship again between P and A only. Okay, but in this case P is known and we want to find what will be the value for A. Now in this equation I use a simple formula, that is A equal to P into A by P I comma N. So instead of using all this complicated formula, I am using this simple representation of that formulas. So what is this one? P is known to me. Okay, A is unknown. This P is known. Okay, I 13%, N is 15 years. So this part can be easily found using the equation compound interest table. So let's try and find it first. Okay, so I'll just show you once. So I'm interested in A by P value. So I'm interested in, first is 13% interest rate. Okay, 10, 12. Okay, 13 is not there, so I have to find using the interpolation. Okay, so similarly, let's say I'm showing to one value, let's say 12%. Okay, so relationship is between P and A. So I have to go to P and A against whatever the number of year, 15 years. So like this I have to go. Okay, so the constant value, if you find using the graph, it is coming as 0.15474, and the value for A is around 7,737. So that's 50,000. If I invest at a rate of interest rate of 13%, every year I can withdraw an amount equal to 7737, and at the end of 15th year nothing is left in the bank, so it is closed account. So this was the relationship between present and the constant annuity amount. Now this is the next problem, where a person is planning for his retirement. He has 8 more years of service. Okay, he would to deposit 18% of salary, his salary, which is around rupees 15,000 at the end of first year. Thereafter he wished to deposit the same amount with an annual increase of rupees 2,000 for remaining 7 years with an interest rate of 10%. Find the total amount at the end of 8th year. So what is happening? A person will be retiring after 8 years. So let's say from today, from today, after 8 years he is going to retire. So he wants to save some amount. So what happens is, every year 18% of his salary, that is around 15,000, he wants to deposit, which he wants to increase at a rate of rupees 2,000 per year. So what he is doing is, first year, at the end of first year he wants to deposit risk 15,000, correct? Now at the end of the second year he wants to increase it by another 2,000 rupees, so he wants to deposit 17,000. At the end of third year he wants to deposit another additional 2,000, that is 19k, then 21k. So this is the series what he is doing. So this is the cash flow diagram. Now, and you have to find what is the future amount he may get at the end of this 8 years. Okay, now this equation cannot be directly solved, and we have to do one intermediate step. So what is the intermediate step is, I have to convert this increasing gradient series into a constant gradient, constant A value, annuity value. If I do this one, and then I can easily calculate the relationship between F and A are easily available. Now how I should convert this one? For that also we already saw one series where it is denoted by A is equal to A dash plus G into A by G I comma N. So here you can see why I am using the plus, because this is increasing in the series. If it is decreasing, that will come as negative. So what is A dash? That is the first year, 15,000. The rate of increase is 2,000, and this A by G, I is 10%, N is 8 number of years. So this constant value can be easily found using the compound interest tables, going to A by G column. Now if you do this one, I got a value of 21,008 rupees. Okay. Now what is happening? This is converted into a series looking like this, where A is 21,008 rupees 0.96 and I want to find the future value. So this is the relationship between again F and A. So I can write where F is unknown, A into F by A, I comma N, where I is 10%, N is 8. And again this value can be found very easily using compound interest table, that is 11.43589, and if I multiply that with A, I get a future value as 2,40,256 rupees. Okay, so this is how we can solve the different problems using compound interest tables. Okay, so we have in today's class we have solved the relationship between P and A, where a person wants to find what is the present value and he wants to find what will be its future values. The relationship between P and F, we have also did the relationship between present worth and annuity, and also the future worth and increasing gradient series. So if you have any questions, you can uh, contact me or you can email me also. Thank you everyone.